Hello friends and students. So in this video segment, let us solve a few gate problems on star delta conversion. So we'll solve three problems, then they are pretty simple here. So what is the first one? So given in gate 14 set 3, for the Y network, R1 is. So it's a direct problem. So R1 is nothing but, I hope you remember. So the best way is to get or to convert a star to a delta. You multiply the resistors, which is 5 into 3 plus 3 into 7.5 plus 5 into 7.5 divided by the value of the resistor, which is exactly opposite R1, which is 7.5. Right? So when I do that, I get the value of R1 as 10 ohms. So this is 75 by 7.5, so we get 10 ohms. So this is the answer, a very simple gate problem which has been given. The second problem given in gate 16, what is our equivalent? So we have a network here. So the first thing what we do is, so here this can be converted to a star network in between. So we observe that I convert this to a star network, all the resistor values are 1. Right? So all these three resistors also will be 1. So what are they? It is multiply the two opposite resistors, which is 1 into 1 is 1, divided by the sum of the resistors, which is 3. So the three resistor values of the star network will be 1 by 3. So now what is the equivalent? So I have 1 and I have three resistors which of the star network, which I've just calculated, which is 1 by 3. Alright, so this is 1, and then again you have 1 here, and then again you have 1 here. Okay, and then you have the delta network, which is 1, 1, and 1. So now these two resistors are in series. So when I add the two resistors in series, what do I get? So I get 1 plus 1 by 3. So 1 plus 1 by 3 would give me 4 by 3. So this network gets now simplified as 4 by 3. So I have just 3 resistors, 4 by 3, 4 by 3 and 4 by 3. So now what do I do? This star network now has to be converted to a delta network here. So now let me write the equivalent value. So I have to convert it to a delta network. So how do I convert it to a delta network? A star network into delta network. So you multiply two resistors, that is 4 by 3 into 4 by 3 plus 4 by 3 into 4 by 3 plus 4 by 3 into 4 by 3 divided by the resistor opposite to it, which is again 4 by 3. So we get 4 by 3 into 4 by 3 is 16 by 9 plus 16 by 9 plus 16 by 9 divided by 4 by 3. Right? So I hope you know the formulas for conversion. Right? So this is 3 into 16 by 9 divided by 4 by 3. It's as simple as that. Alright, so 3 and 9 gets cancelled here, so it again gets cancelled, 4 and 16, so 4s are 3 gets cancelled, so the answer is 4. So now the resistance value of the delta network is 4. So now let me redraw the circuit. I have 1 ohm and again 1 ohm. And then you have another delta network where the resistor value is 4. So this is 4, 4 and 4. Now these two resistors are in parallel. So what is the equivalent resistance? So the equivalent resistance is 4 into 1 divided by 4 plus 1, which is 4 by 5. So this is 4 by 5, 4 by 5, 4 by 5. Alright, so this can now be written as, so I have 4 by 5, then I have 4 by 5, and then I have again 4 by 5 here. And this is A and B. Now these two are in series, so 4 by 5 plus 4 by 5. Okay, so now this is, I have 4 by 5 here. So 4 by 5 plus 4 by 5, which is nothing but 8 by 5. So 8 by 5 will now be in parallel with 4 by 5. So now these two resistors are in parallel. So let me find the equivalent resistance. So R equivalent is multiply the two resistors divided by the sum. Alright, so therefore we get 8 4s are 32 divided by 25, and here you have 12 by 5. Okay, so 5 5s are gets cancelled here. So now if I again do the cancellation, what happens? So 4 3s are, 4 8s are, you get 8 by 15. So 8 by 15 ohms is the right answer. So the correct answer is D. So D happens to be the right answer, right? So this in fact is a very simple problem, right? So wherein they have actually asked you to find the equivalent resistance, but it is a bit time consuming, right? So it takes some time for you to solve it, but does not take a lot of time because the values are 1, right? So everywhere you get the same value. So whenever you convert star to delta or delta to star, all the resistor values would be the same. So if you're a bit quick, you will be able to solve this problem very easily because it is a very simple problem here. So let's move on with the next one. So this is another problem, a 1-mark problem given in GATE 2013. So consider a delta connection of resistors and its equivalent star connection. If all the delta connections are scaled by a factor k, so this is the delta connection. So if all the resistors are scaled by a value k, the elements of the corresponding star equivalent will be scaled by a factor. So the question is, how much would the resistors of this star network be scaled? Right, so again a very simple problem. So now let this star network be given here, right? So if I need to find, say, RC, so what is RC? It is nothing but RB into RA divided by the sum of resistors, RA plus RB plus RC. So this is capital C, okay, RB and RA. So what am I doing? Each of the resistor values of the delta network is scaled by k. So what happens? So I get k squared into RA into RB divided by k. If I take k common, I get RA plus RB plus RC. So k gets cancelled. So this is the original value of RC if the resistors are not scaled, but here I have k into a value which is R. Let me call it as R dash. So this is R dash here. So what happens? So the resistors of the star network also would be scaled by a factor k. So therefore the answer is B. So B is the right answer. So we have gone through a few problems, star delta network conversion problems given in GATE. So we have solved 3 problems. So I hope you have found them interesting and informative. So in GATE, of course, some problems will be very difficult and some may be easy, but they may be time consuming. But very rarely you do find problems which are very simple and very easy and you will be able to solve it very quickly. But the problem is in GATE, of course, you have a vast syllabus. So the question is, how quickly you solve the problems and how quickly you recollect the formulas and the concepts. So that is quite challenging in GATE. So I hope all these problems have really helped you and have given you an insight as to how you can go about solving problems, basically dealing with star delta conversion. So to view all the other videos in network analysis, do click on the I icon or go through the playlist network analysis, and do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads, and thanks for watching.